Now let's move on to step number 3. Step number 3 basically goes for finding the S11 of the circuit and the input impedance. In fact, the input impedance is the real thing that I want, because once I know my input impedance, then actually there are techniques that will allow me to find the actual circuit realization. So let's go step by step. I do know the S21, and in the amplitude domain, I know that S21 square plus S11 square should be equal to 1 if I have a lossless filter. And we will assume we will have lossless filters, at least low loss filters, and that means if I translate this equation now to the domain, the S domain, I basically must satisfy this requirement right here. And so it's really that equation that will help me find the unknown S11. So the S11 of S times S11 of minus S is basically a function of what I already know. And if you do the math, it will turn out that you will have some very similar properties for S11 as we had for S21. So first of all, it turns out that the S11 will have exactly the same poles as the S21. So if you have chosen the left-hand plane poles for S21, then you're guaranteed to have the left-hand plane poles for S11. The zeros will be different, but they will appear again in groups of 4 or 2, and that's something again very similar to what happened for my S21. So once you do know the S11, which again is just a matter of algebra, then the next step is to find the input impedance, which we already know it's the equation that we have right here. And the interesting thing about the input impedance as well as for the S11 is that we will end up having two choices, two solutions. So we will actually see how do we implement those two solutions, and it turns out that in most practical cases, one is more desirable than the other. And so we will see why that's the case later on. So let me give you an example. I'm going to take the third order Butterworth example that we worked out before. So this is the transfer function that we have. The step right here basically finds the numerator of the S11. So if you go back to your slides, you will see that the numerator is equal to this, where g of s is the Horwitz polynomial here, and f of s is basically equal to 1. And it's interesting that h of s in that case will basically have two solutions, plus or minus s cube. Because when you multiply plus or minus s cube, and then you take the h of s times h of negative s, you will basically end up with negative s to the 6, which is what is needed. So one has to be careful, because this is what really the equations will give us, and from there we have to guess h of s, which again will always end up having two solutions. And so that means that your S11 will basically end up having two solutions, shown right here. And that basically means that your input impedance, which is given by this guy here, will end up having two solutions. So if you choose h of s to be s to the cube, then your input impedance will basically be this. While on the other hand, if you choose h of s, and I don't have it here, to be negative s cube, basically you'll have a different solution, which we will see in a little bit.